after the 1:30 update. We're talking about supercomputer Graham, a $17 million supercomputer, the largest of any Canadian university, with more than 50 petabytes of storage, 50 million gigabytes, 50 million gigs. What is it designed to do? What is special about it? What do they want to do with it? We're going to chat with Professor Scott Hopkins, assistant professor in the chemistry department at the University of Waterloo, and Greg Newby from Compute Canada. We'll talk about Graham, the supercomputer, on the Tech Spotlight, which is next on 570 News Midday. Glenn Peltier filling in on 570 News. Welcome back to 570 News Midday. Glenn Peltier filling in. Great to have you along. And really happy to be here. This has been such a great experience, I must tell you. Talking to such interesting people. You talk about interesting people. Oh my goodness, if we can get these guys on the line. I mean, this is just fascinating stuff. You know, you never really know in this business what you're going to be doing completely from day to day. And lo and behold, I'm going to be talking to folks about floating point operations per second. Petabytes instead of gigabytes. Let's get both of these guys on here. It's the Tech Spotlight, and we're on the line with Professor Scott Hopkins. He's the assistant professor of the chemistry department at the University of Waterloo. And we're also waiting to connect with Greg Newby of Compute Canada, where he is their chief technical officer. I mean, did you hear about this? This is incredible. And there's probably only one guy on staff who knows, who might have an idea, and that's Jason, our engineer. He's the only guy I know, Jason Sharp and Mike McCabe, who might have a clue as to not exactly what this thing can do, but the basics of this supercomputer. Last week, the University of Waterloo and Compute Canada unveiled a new supercomputer, the largest computer of its type at any Canadian university. It is named Graham. It will help researchers generate more results by sharing immense volumes of data with a storage system of more than 50 million gigabytes, or as I described earlier, a petabyte. I've never heard the word petabyte before. This particular computer has that much storage power. It has more than 50 petabytes of storage. 1 petabyte is equal to 1 million gigabytes. So the aforementioned Scott Hopkins and Greg Newby are on the line. Gentlemen, thanks for joining me today.
Thank you very much for having me.
This is exciting stuff. I mean, I'm all ears, gentlemen. So let's begin. Are you both there, Greg, Scott?
Scott's here, yeah.
And this is Greg. Hi there.
Great to hear. Just to repeat, Scott is the assistant professor in the chemistry department at the University of Waterloo, and Greg Newby is the chief technical officer with Compute Canada. Before we begin, just Greg, if you will, what is Compute Canada, and what is your role in this project with the university?
We call Compute Canada the national platform for advanced research computing. Advanced research computing is anything beyond the desktop. So if you're a researcher like Scott and you've exceeded what your laptop or your workstation can do, then you kind of graduate to Compute Canada. But it's a member organization. It's 37 research universities like University of Waterloo and some research hospitals, all working together to operate the equipment, provide all the support, because these big BCs are kind of hard to use, so they provide the user support and software and training and stuff like that. And Compute Canada is really the coordinating organization, and it's a project that's under something called Canada Foundation for Innovation. These guys run a lot of the advanced research computing and other infrastructure projects. Like anything that's big, CFI tends to be involved with, and Compute Canada is pretty big.
And where are you right now? Where are you looking? Where is Compute Canada?
Well, the Compute Canada offices are down near Union Station in Toronto on University Ave.
Right.
But today I'm actually in my home office, which is up near Bancroft, Ontario.
Oh, God's country.
It is. It's nice.
Oh.
We're in the place where everyone else goes for vacation.
Oh my God! I spent some many a day up in Bancroft in that area. And Scott, I mentioned that you're in the chemistry department. Is it that particular the department that will make greatest use of this computer? I mean, what is your relationship to the project?
I think there are lots of departments and lots of researchers, not just in Waterloo, but across the country, that will make use of the new Graham computer. I think in terms of chemistry, I mean, it's becoming more and more an exercise in applied math. So that's where chemists tend to make use of supercomputing these days, mostly for trying to do quantum chemical modeling or the like. Although there's a lot of excitement and hype around the idea of artificial intelligence and machine learning being applied to chemistry. So had I to take an educated guess, I'd say over the next 4 or 5 years, that's probably the direction that people are going to go in. Most of my work right now is centered around quantum mechanical modeling, though.
I want to get you guys both, in your own estimation, to define what a supercomputer is. But before I do that, I'll preface it by saying that the strict definition is a supercomputer is a computer with a high level of computing performance compared to a general purpose computer. Performance of a supercomputer is measured in floating point operations per second, or flops, instead of, and this is why I'm saying I want to preface this and get these guys to explain it. Let me repeat this. Performance of a supercomputer is measured in floating point operations per second instead of million instructions per second, or MIPS. As of 2 years ago, when the latest stats were available, there are supercomputers which can perform up to quadrillions, that's quadrillions, of floating point operations per second. Before I get you to define what a supercomputer is, what is a floating point operation? Do you guys know?
Well, sure. Yeah, floating point operation is really just a math operation. So 2 plus 2 equals 4. That would be one type of operation. If it was just 2 plus 2, it might be a integer. But if it's like 2.0 or 2.1, then it becomes a floating point because there's a decimal in there. And mostly the type of science that people like Scott do is using floating point math. It's just a way of doing precise math. So if you're doing engineering, you're doing any sort of simulation, you're going to want that decimal point to move around. And that's all it is.
Yeah, that's exactly right. So typically we carry 8 to 10 decimal places in any calculation that we would do. So for that reason, we need to use floating point numbers. Floating point operations per second are important to us.
All right, gentlemen, I leave it to you now to tell me, when we say supercomputer, what are we talking about? What is a supercomputer as you would describe it? Scott, go ahead.
So I think you can find any number of definitions on the internet for what a supercomputer is. I think a good one is something that, say, runs at least 100 times faster than a PC might, or a server might. But realistically, when you're talking about big supercomputers like Graham or these other computers that are in the top 100 in the world, you're talking about things that are hundreds of thousands of times more powerful in terms of the operations per second that these guys can handle.
Greg, would you add to that?
That's really exactly right, and the definition you had is quite good also. The fact is that a supercomputer is a moving target, so the cell phone that you have in your pocket these days, well, 20 years ago, a supercomputer had that kind of computing power, and now you just carry it around. So the supercomputer of today is going to be something that everyone has, maybe in their car, maybe in their pocket, maybe in their house, in another, say 10 or 20 years. So it's really something that is simply at that leading edge. And the other characteristic maybe that Scott didn't mention is a supercomputer like Graham is made up of, in the case of Graham, about 1,000 separate computers. Each of those computers is only a little bit stronger, a little bit more powerful than your laptop, or like a desktop workstation, or the type of computer you might have in your workplace. Maybe twice as powerful, maybe 3 times as powerful.
Are you guys?
But we put thousands together.
Yeah, and I think the important thing is that the architecture itself and the people that run it are sort of tailored to be in the right place, the right environment to accelerate the research, the work that's being done on that unit as well.
All right, I want you guys to try and I'm going to say something, and I want you guys to put it in perspective, if you can, use an analogy if you can. The fastest supercomputer in the world is the Sunway Taihulite in mainland China. Are you familiar with this thing?
Oh, yeah.
Yeah, I know of.
Okay,
I think Greg
okay.
would be more of an expert here, though.
Okay. With a LINPACK benchmark score of 93 P-flops, exceeding the previous record holder, and I can go on, but I have no idea what that means. Can you put it in perspective for us? This has it has earned the distinction of being the fastest supercomputer in the world. What does it do? How fast is it? Like, what is special about this thing? And then when I was talking more about Graham.
To give you an idea as to how things change, there's a new, faster supercomputer every year or two. So it's always like a leapfrog type of thing, almost like an arms race, because the Chinese and the Americans tend to be competing for it. This computer in China is about 1,000 times faster than Graham. I'm sorry, not 1,000, 100, maybe 50 to 100 times faster, depending on different measures you can use. So 50 to 100 times faster than a computer that's already taking up the whole room at the University of Waterloo. I mean, this is a tremendous system at the University of Waterloo. And in turn, Graham is maybe a couple thousand times faster than your desktop computer. So that gives you an idea. You know, you're multiplying your home computer, your laptop, by 1,000 times and another 100 or so times, and that's what this computer is doing. And so the question is, what can you do with it? And the answer is, you can solve some of the problems that just can't be done, or they would take, literally close to forever or many, many years to solve on other computers. And that would be something like a physics simulation. So, for example, some of the early universe, how did the Big Bang work, stuff like that. Maybe material science or chemistry, where they're trying to figure out molecules or discover a new drug. So these are the types of things that you can do on a larger scale or just much, much faster on a bigger system. But it's interesting because there's a bunch of things you can't do. So, for example, it wouldn't make your MP3 player work any better. It wouldn't help with Excel, or it wouldn't help you figure out your taxes any better. So there's a bunch of problems that don't do well with supercomputers. And what we do, of course, is we make sure that people that have problems that will do better with supercomputers, they have access to those tools. And that's really what Compute Canada is trying to do, is make those available to the researchers.
Scott, anything to add to that?
Yeah, so I mean, this was something that interested me as well. So I actually looked up to see how many flops an Xbox 360 would have, just to put it in context. And an Xbox 360 has about 0.25 teraflops. So the Graham supercomputer is about 10,000 times more powerful than an Xbox, a current Xbox. And something like that is really important for my research because the kinds of things that I do are looking at complex nanocluster systems. So I have a very intricate model that I need to apply to try to extract properties and make predictions about how these things are going to work. And just to put it in context, I've been using the previous generation of supercomputer here at Waterloo for the last 5 years. And over the last 5 years, I've accrued something around 1.5 to 2 millennia of computing time on these supercomputers, just to try to churn through some of the problems that we're dealing with computationally.
I've heard both you guys mention, in reference to the supercomputer's attributes, you both use the word speed. Speed. Is that the key aspect of a supercomputer as opposed to storage?
It's both, and in practice, the speed doesn't come from like the CPU running faster, because the CPUs aren't that much faster than your average CPU these days. In fact, sometimes they're even a little slower, but it's by working them together. So you get more speed by all working together. So it's a little like, if you have a bunch of horses all pulling a carriage together, something like that, where you're harnessing the parallelism rather than doing it just faster, but one at a time.
Mm-hmm.
I was thinking too, when I heard the word supercomputer, I think of something. I'm almost ascribing a human quality to it, and I inferred that it meant that this computer was, quote unquote, my words, more intelligent than other computers. But that assumes that computers have intelligence. Am I off base there?
Well, it's not human intelligence, of course, and these computers, the Graham computer, no one needs to worry in Waterloo. The Graham computer is not going to wake up and decide it wants to take over the world, or even it wants to take over a Kitchener-Waterloo area. You know, the Graham computer is not going to spontaneously become human-like intelligent. But it does have characteristics for data processing that are similar in some ways to the human brain, and it has the ability to have multiple things going on, just like the human brain does. So some of us can walk and chew gum at the same time. Most of us can talk and walk at the same time, and maybe drive and talk on the phone, these types of things. Well, computers that we have can do multiple tasks at the same time. So there's a lot of interesting parallels, but it's not human-like intelligence, but it is an ability to handle a bunch of data and to come up with the right answers to a bunch of different problems, and to do simultaneous things that themselves are maybe all complicated.
How will Graham essentially be used? What is its main purpose?
So on my side of things, I think there are sort of three main purposes that you'd have for a supercomputer in terms of the research. The first two are sort of traditional. There would be, developing theory and mathematical models on one side, and this has application in all sorts of things. Greg mentioned earlier modeling galaxy formation and cosmological events, but that runs the whole course through to economics, population dynamics, modeling and simulating jet engines and heart valves. The list goes on for this sort of thing. The new use that's new to scientists. It's been around for a while in terms of computer science, is this idea of machine learning, where really the supercomputer is going to come into its own because it can handle really big data, and it has the wherewithal to be able to process that big data in a very fast and sensible way, as a machine would be able to do. And that's something that people aren't good at, right? Handling too much data, you get sort of a mental overflow, whereas a machine can learn quite quickly and regularly. And on the other side of that, there are things that the human brain can do very well that machines can't do, right? So face recognition, that's something that we do naturally. You see a friend and say hello, but you'd be surprised how complicated that is to try to get a machine to do well. And there are numerous examples like that.
Do you think a computer will ever answer the question of the origin of the universe?
That's a deep philosophical question. I'm not sure if a computer will ever answer that. It's possible, maybe, that a human can answer that
in conjunction with a computer.
Yeah, exactly. Yeah.
Right.
And there are theories out there as to the origin of the universe already. Whether we'll ever be able to prove that with any sort of evidence, I don't know. I think right now it's more of an exercise in logical mathematics.
Well, what is Hawking using? Is he working on a supercomputer?
I think Hawking would have his students perhaps run simulations on a supercomputer, but my understanding is a lot of what he does is more mental, right? He just thinks very deeply and focused on particular subjects, and essentially works theories out in his head before he spends the time to divulge what he's thought. I've heard some people say that the fact that he has to speak through his talking box, that's actually helped him with some of his work, because he tries to refine his ideas before he says anything.
Gentlemen, how is this computer going to set the University of Waterloo apart from its, I guess competitors is the wrong word, but to what extent will it give Canadian researchers a leg up on their competition?
So the nice thing about Graham at the University of Waterloo is that it is under the Compute Canada envelope, right? So Greg can speak to this a little bit more, but there are actually 4 new sites that have recently been announced. There's 2 in BC, one at UVic and one at Simon Fraser. There's another supercomputer called Niagara that's going to come online at U of T very soon, and then the Graham computer here in Waterloo. And all of these are interconnected, right? So you can access these via the internet. So even though I'm living and working in Waterloo, I don't necessarily have to use Graham. If I feel that Cedar at Simon Fraser University would be a better fit for my needs, I can potentially work there. So the fact that we have that interconnectedness and collegiate atmosphere, I think, across the country is very beneficial to us in terms of trying to compete with some of the bigger dogs, we'll say, like China and the U.S.
I'll leave this. I guess you both know the answer to this, but I guess since Scott works there, why was it called? Why did you call it Graham?
So Graham was named after Wes Graham. He was a computational scientist here at the University of Waterloo back in the 60s and 70s, I think right up through the 80s, actually. And he was actually the first director of the computing center here at the University of Waterloo. So we felt it would be a nice honor to name the newest supercomputer after him.
Nicely done. Gentlemen, thank you so much for your time. Fascinating.
It's been a real pleasure.
Yes, thank you very much.
Thank you. Scott Hopkins, Assistant Professor in the Department of Chemistry at the University of Waterloo, and Greg Newby, the CTO of Compute Canada. Exciting stuff. Thank you, gentlemen. Have a great day. It is bigger than any other supercomputer at any other Canadian university. Graham, the $17 million supercomputer housed at the University of Waterloo. Thank you for listening. We're going to come back with parting thoughts as 570 News Midday continues. Glenn Peltier filling in on 570 News.